We conclude the topic of random number generation with a look at the Lehmer algorithm, the linear congruential generator. It's what you see on the screen. It starts with a seed and then recursively generates the next number in the sequence with modular arithmetic, m being the modulus, a being the multiplier, and the number xi is normalized by m to obtain the uniform deviate. M0 is the period of generator, and the numbers m and a are typically chosen depending on the word size of the machine, and it's found that this generator is a full period generator only if the modulus is a prime number and a is a primitive root of m. Now this generator has been studied extensively, and the best set of parameters m and a, the best RNG, it's found to be when m is the Mersenne prime 2 to the power 31 minus 1 and a is 7 to the power of 5. In this case, this generator is a full period generator, and m0 is m minus 1. And these values were first proposed for A it was by Lewis et al. In 1969, and the value of m was by Lehmer himself in his original work in 1948. I have listed this excellent paper by Park and Miller, which discusses this algorithm and others. So now let's just end this discussion with one or two small examples of the Lehmer algorithm. Let's say that let's have the modulus as 2 to the power 3 minus 1 and the multiplier a as 2. So what would be the period of this generator? If you want to work this through, then please pause the video. Otherwise, let me present the solution. Let's choose the seed as 1, and then we find that the period is 1. Well, the period is 3. The sequence is 1, 2, 4, and then it starts repeating itself. If you choose a different seed, then you hit another sequence, and obviously there is no intersection between the two sequences. If on the other hand we choose the multiplier as 3, then you will find that this indeed becomes a full period generator. So the choice of the multiplier is actually very important. Let's look at the next Mersenne prime 2 to the power 5 minus 1 as the modulus, and if a is 2, then what would be the period of this generator? If you again want to work this out, then please pause the video. Otherwise, it turns out that depending on the seed, you get different sequences, and none of them is a full period generator. The period is 5, and there are 6 such sequences. On the other hand, if a is chosen to be 3, then this generator indeed becomes a full period generator.